Okay, you don't have to be given the context, as we'll see in this example. So given this relationship between p and x, they want us to find dp dt when x is 2 and dx dt is 3. So we need dp dt. So using the chain rule, dp dt will be dp d something times d something dt. So the d somethings would cancel and leave me dp dt. What's my additional variable in the information we're given? It's x. I've got a p in terms of x. So in this case, the d something, the cloud, is going to be x. So therefore, what we're working with is dp dt is dp dx times dx dt. They're giving us dx dt, it's 3, and I'm also told the relationship between p and x. So dx dt equals 3, and p equals x bracket x squared plus 4 to the power of a half. So when I'm going to differentiate that, I can see I've got a product. I've got the x multiplied by that. So this is going to be a product rule. So let u equal x, v equal x squared plus 4 to the power of a half. Differentiate this and we get 1. Differentiate that and I've got a chain rule. So if I cover up the embedded function, it's going to be a half finger to the minus a half. Multiplied by differential of the finger, what we covered up, which is going to be 2x. Half and the 2 will cancel. So I've got x bracket x squared plus 4 to the minus half. So therefore dp dx, which is what we want, is now building this. So it's going to be v du dx. So it's going to be that times 1, which is just x squared plus 4 to the power of a half, plus u dv dx, which will be x times that, so I've got x squared plus 4 to the power of a half, plus x squared times x squared plus 4 to the power of a minus a half. So I've got my dx dt, I've got my dp dx, so if I sub those into my chain rule, I get dp dt equals dp dx, which is this beast, multiplied by dx dt, which is times 3. Now, this isn't a show that, so we don't have to worry about tidying that up any further than it is, because they're giving me the value of x that they want us to work out. So they want to find dp dt when x equals 2. So rather than now getting swallowed up in algebra, let's do some evaluating with that value of x. So we're going to have 2 squared plus 4 to the power of a half, plus 2 squared bracket 2 squared plus 4 to the minus a half times 3. So that's 4 plus 4, that's going to be square root of 8, plus 4 over, so that's also going to be the square root of 8, but because of the negative indice, that's going to look like that, times 3. And let's take that to simplify further. So if I leave the 3 out there for the time being, I can have this all over root 8, and you'd end up with root 8 times root 8 plus 4 times 1 all times 3. You could probably, I'll keep going here, but we could probably dive in at that point and wind that into the calculator and it'll tidy it up for us, but let's keep going. So this is going to be 8 plus 4 is 12 over root 8 times 3. So that's going to be 36 over root 8. We'd rationalize the denominator then by multiplying by root 8 over root 8. So that would be 36 root 8 over 8. Root 8 is 4 root 2. No, it isn't, it's 2 root 2. Because we can write root 8 as 4 times 2 over 8. So that's going to be 36 over 8 times 2 root 2. Just keep going a little bit further, which is 32 goes into 8 4 times. So we've got 36 over 4 root 2, and 4 goes into 36 9 times, so you end up with 9 root 2 as your final answer. Oh, that's a squiggle underneath it, nothing else. So if we wanted to go straight in at this point, we could have written this as root, open bracket, root 8 plus fraction 4 over root 8 close bracket times 3, and that should give us straight away 9 root 2. So again, the power of your calculator is mighty, and there's nothing stopping you at that point or even before that, once you've decided to substitute, to evaluate that particular answer. So as with lots of things in A-level maths, what we've got there is the first couple of lines is new knowledge, then it's product rule with an embedded chain rule, which we've been practicing for a number of weeks, and then evaluating the algebra from that. So it's a little bit of new knowledge, then lots of practice at older experienced things.